Verifying limits. The process of limit verification has 3 steps in 2 major phases. So phase 1 includes 2 steps. Step 1 is to calculate the left-hand limit. Step 2 is to calculate the right-hand limit. Then in phase 2, there's 1 step, and it's determining whether or not the left-hand limit and right-hand limit are equivalent. Thus, we can simplify this to say, if the limit of f of x as x approaches c from the left is equal to the limit of f of x as x approaches c from the right, a limit exists at x equals c. So here's an example. Verify whether a limit exists at x equals 1 for the function f of x. So here we have f of x being a function in the piecewise format. So first we're going to find the limit as x approaches 1 from the right. So the limit of f of x as x approaches 1 from the right equals -4. So what we're doing here, so it's 1 from the right, so that means greater than 1. So where x is greater than 1. So we're going to apply this bit of the function. So limit of f of x as x approaches 1 from the right is equal to -4 times 1 squared minus 2. So that equals -4 minus 2. So the limit of f of x as x approaches 1 from the right is equal to -6. Okay, so now we'll try to find the limit of f of x as x approaches 1 from the left. So the limit of f of x as x approaches 1 from the left is equal to 1 from the left is where x is less than 1. So we're going to apply this bit of the formula, of the function rather. So this is equal to 1 squared minus 6 times 1 plus 2. This is equal to 1 minus 6 plus 2. And so the limit of f of x as x approaches 1 from the left is equal to -3. So our conclusion statement will be, since the limit of f of x as x approaches 1 from the left does not equal the limit of f of x as x approaches 1 from the right, the limit of f of x as x approaches 1 is equals does not exist, or just does not exist, signified by these 3 letters. Construct the graph of the function f of x and verify the limit as x approaches c. So we're not really going to construct the graph because I have a picture of it that will show up in a bit, but we can visualize the graph. So here we see that we have an absolute value part in the function, and this is actually not a fraction, it's just a line. So it's another piecewise formatted function. So it's important to be able to visualize graphs before trying to figure out limits or verify limits, especially if one does not have a graphing calculator or some sort of graphing program. You should know exactly what the graph, or have a general idea of what the graph will look like before you attempt to make a conclusion from the function. So we know that it has an absolute value part. So what does that look like? It means that essentially the function is positive. So we know that if this was just absolute value of x, if this is our axes, then this is what a typical absolute value function looks like. However, this is x minus 2, the absolute value of x minus 2. And this minus 2, we typically think it would go to the left, but it actually moves over to the right. And looks like that. But we also have this bit down here as x is greater than, when x is greater than or equal to 3, that it's equal to -1. So we can continue our graph at 3. We know that it's when x is greater than or equal to 3, it's -1. And so we also know that there's an open circle at 3 here, and this part doesn't exist. So let's see how the real graph looks. So yeah, pretty close. But because the limitations of the graphing program, we know there's a point. There's a point here and no point here, so it's an open circle essentially. Okay, so let's get back to the problem. Construct the graph of the function. Okay, sure, we did that. And verify the limit as x is approaching c. So what we need to do first is find f of c. So what is this? F of c is equal to -1. And now we look at the because of the location of x. So f of c is equal to 3. That means x is equal to 3. So which do we use? This is x is less than 3. No, that's not quite 3. However, this is x is greater than or equal to. So in this case, we use this one because x is equal to 3, indicated by this lower line of the inequality statement. So f of c is equal to -1. So now we'll look at the limit of f of x approaching 3. So the limit of f of x as x approaches 3 from the right is equal to, so here's 3 approaching from the right, -1. So the limit of f of x as x approaches 3 from the left is equal to 1. So here we can make our conclusion statement. So though f of c exists, since the limit of f of x as x approaches 3 from the right does not equal the limit of f of x as x approaches 3 from the left, the limit of f of x as x approaches 3 does not exist.